Okay, in this video we go over material that's in both chapters 2 and 3 that we skipped originally. Not that it's not important, it's very important, but I wanted to discuss these together. And the data that we're going to use is the scatter plot and correlation data. Chapter 2, one of the topics is how to build scatter plots. And then the corresponding statistics are correlations and regression statistics. So go ahead and grab this data, download it, and when you open it, you'll see things that look like this. And we're going to really focus on the first two worksheets. And what I want to do is I want to be able to understand the relationship between how much money I spend in advertising and the subsequent sales. So I spend money in advertising, I run commercials, I buy ads, and then does that increase my sales? And I want to know if that's true or not. And so what we're going to do is build a scatter plot of that. And what we can control, we call our X variable, and the result is our Y variable. What we can control is typically called an independent variable. I think of it as the dial, what we're turning. And then the result is the dependent variable. Dependent. The result. So this is like the cause, this is like the effect. So if we change our advertising, what does that do to sales? So if you grab the data and you go up here to insert scatter plot, look what happens. When you hover over this, it says insert a scatter plot. The nickname for the scatter plot is an XY chart. So you really need to make sure that your data is formatted where the X data set is to the left of the Y data set. And you grab that and you go build a scatter plot. Grab the first one, don't use any lines, just grab the first one. And just like that, what you get is a relationship between advertising dollars and sales dollars. And you can see that there's pretty much a relationship that when this number is small, and as you increase this, this goes up. So we can see that there's a positive relationship. There's a positive correlation between advertising and this. If I right-click on any of the data points, if I right-click on the data point and add a trend line, what this does is it puts a best fit. It puts a theoretical model. And the default is linear, and we're always going to use linear in this class. And go ahead and get the equation and the R squared. So just like that, we're able to build a theoretical model that said, based on all of the data, the best fit line is Y, and Y is my result, so my sales volume is equal to 4.43 times X times my advertising expenditure plus 66.212. So that's just an equation of a line where 66.212 is the intercept, it's about right there, and this is the slope, 4.43. So for every dollar spent in advertising, the benefit is $4.43 in sales. The other statistic that we get is something called the correlation coefficient squared. So R squared, and they take this and it looks like that. That is the squared correlation coefficient. It's a number between 0 and 1. If it's close to 1, that means it's a very strong relationship. If it's close to 0, it means a very weak relationship. Since R is almost 1, it's like 87. That's really close. That's close to 1. So we have a pretty strong relationship. And you can just see from the picture that the dotted line, the theoretical line, is really close to these data points. Okay, so that's the act. Let's do this. Let's just practice this a couple more times. I'm going to go to this other data set. And what I want to do is try to determine how many games I'm going to win, that's Y, as a function of these statistics, these NFL statistics. This is offensive rush yards, how far I rush the ball, or how well I throw the ball, my punter, the average yards punted, field goal percentage, turnover differential, penalty yards, how well my team stops the run, how well my team stops the pass. Now we're not going to do all of these, but to do these, I've got to build an XY chart. So the first thing I'm going to do is I'm going to take my Y's and put them to the right. I'm going to copy that and put it here. Now let's just do this one. I'm going to grab this, insert, that again. Don't, and then add a trend line. Get these two like that. So this, what we're doing is predicting games won as a function of opponent pass yards. And we did this model. Well, which is the better model? You can see the R squared here is 0.879. The R squared here is 0.06. It's not nearly as strong. And so there is data and there is a line going down showing that if I stop the pass, my wins increase. When I have low pass yards, my wins increase, but the R squared isn't as strong. And all that means is that a lot of the lines, the dots, aren't close to the line like they are here. Let's do another one. I'll do the same thing. I'm going to now grab the opponent rush yards, and I'm going to grab this data. Now, how did I grab these data that are two separate pieces? So I'm going to left click right in the center, drag down. I'm not touching anything or the mouse or the keyboard. Then I hold the control key down, and then I go left click again on my mouse and drag down, and I can build another chart. Same thing, right click, add a trend line, and we just look at those two together. Scoot them down a little bit. Which one is the stronger or the better model? Well, it certainly looks like this one is, because it has a higher R squared. So stopping the run, that's what the second stat is, opponent rush yards. If I stop the run, that has a stronger relationship to winning as does stopping the pass based on 1976 data. So this is very important in terms of understanding what are the things that drive success. In this case, success is winning games. This is more important. This measure is much more important than this measure. Let's do one more. I'm going to go over here to rush yards. Actually, let's go to pass yards and do that against games won. Build a scatter plot. Right click on the data point. Pick the equation and the curve, fit it up. Let's pull this one down. So now we got 3. It's getting hard to read, but this is still the most important because the R squared is 0.43. This one is pretty important, but not as important as this one. Its R squared is 23% or 0.233. And remember, that's telling you the relative, how important the model is, and from 0 to 1. So we can see that pass yards certainly impacts wins. The more pass yards you have, the more you win. But it's not as important as having a defense that stops the run. So that's what regression lets you do, is it takes numbers and you can build relationships and understand the strength of the relationships between two data sets. This is R squared. That's the squared correlation coefficient. If I would just take R, it would be the square root of R squared. And what this is called is the correlation coefficient. It's a number between -1, it's also a measure of this. This is the one we typically use, but understand that correlation coefficient is a number between -1 and 1. Thanks.